scheduled talks. We're going to have a bunch of just lightning rounds of 5, 10, 15 minutes of a variety of topics. So I don't know if we're planning on the. Yeah, if anybody feels like talking on a topic for a handful of minutes, please let us know, and more than welcome to join us. Let's see, hiring or looking. We can handle that off camera if you want. If anybody's hiring, which we are, we're going to be looking. Feel free to pick up afterwards. Thanks to our sponsor, NextNet. Who's on the way?
Food is on the way. Pizza is forthcoming.
Okay.
Yes.
Already covered speakers. Azure Source, latest edition, volume 57. If you haven't checked it out, talked about past Summit. Sam, what was that?
It's a conference. They get a bunch of Azure related announcements. That's the bulk of the Azure Source.
So if you're ever looking for more info on what's the latest and greatest in Azure, check out the Azure Source blog.
Comes out on Monday.
Code Campus this weekend, I believe it's all booked up at this point, right?
It is booked up, but we will have the live stream. So if you go out to mixer.com/philly.net, all spelled out DOTNET, you'll be able to see the live stream for both Friday and Saturday.
Okay. What on Friday is going to be streamed?
So Friday we're going to do Chris Gomez talking about Git and I think GitHub and Git tools. So he's doing a great 7-hour session around that. And
Saturday, the Envision Room is broadcast?
Anything in the Envisioning Center will be broadcast.
Okay. So if you guys look at the grid, check out the schedule, look at the Saturday grid, anything that's in the Envision Room.
Recorded too? Rich, recorded and posted?
Absolutely.
Okay. So if you're not able to wake up at 8:30 in the morning on Saturday, which I have to this time, but normally wouldn't, it'll be posted on YouTube later on. Hey, guys. Alright, so there's a Princeton Azure Meetup December 4th. It's Azure Data Metrics. Philly.net on the 5th. Azure DevOps, I assume it's Brian. And Azure Data Fest is 7th, which is a Friday, and that's a $20 sign-up fee. And it's
I reference light lunch, data, big data, AI, some other Azure stuff.
And then we've got sponsor next to that, and I guess hand over to Ned.
All right. Sweet. Just grasp. I will plug in, and hopefully we can get that to work successfully.
Does that look good?
Should I jump to 3?
No.
Jump to 3. Sorry. No worries. I was blocking the screen anyway. This makes sense.
I know. I'll tell you about the
Oh. Alright, there we go. So, hello everybody. I am Ned Bellavance. I'm a Microsoft MVP in Cloud Data Center Management, as may have been mentioned before. I am on Twitter at Ned1313, and I have a website, nedinthecloud.com. Well, that GitHub link is wrong. But everything else on here is right. This is automating Azure with Terraform, now with more bacon. Everybody needs a little more bacon in their automation life. Has anybody used Terraform already? One person. Hey. The imagine.
take that back. I ran a script last night. I was going through it. Yeah.
Well, there you go.
Yeah, so.
For those of you who aren't familiar with Terraform, it takes the approach of declarative versus imperative when it comes to deploying infrastructure. What do I mean by that? To give an example that has nothing to do with Azure, let's say you want to make a fluffer nutter sandwich. If you were doing this in an imperative way, like you would with PowerShell or some other scripting language, you would give it the step-by-step of everything it needs to do to make you that delicious fluffer nutter sandwich. You would tell it to get peanut butter and the marshmallow fluff, get bread, get a knife, spread that peanut butter and the marshmallow and put the slices together. Bam, you got a sandwich. But that's a lot of work. It would be a lot easier if you could just say, hey, I want a sandwich that's a fluffer nutter with these two ingredients. Go make it happen. And that's what declarative's all about, is I give you what I want as the end result with some information, and then it's up to you to go work your magic. So it's kind of the equivalent of yelling into the kitchen, Mom, I want a fluffer nutter, as opposed to going and doing it all yourself. So one of the programs that I use to accomplish this goal is HashiCorp's Terraform. HashiCorp is the company, Terraform is the product. Terraform is an open source product, it's free to use. They do have a paid-for version of Terraform called Terraform Enterprise that adds a bunch of bells and whistles like role-based access control, a GUI, a dashboard, and some other things. I've never used it, but some people like it apparently. What does Terraform bring to the table? Well, first of all, like I said, it is declarative in nature. So when you're defining infrastructure within Terraform, you're doing that using a declarative syntax. If anybody's used Azure Resource Manager templates, you'll be familiar with that sort of declarative look and feel. It's idempotent, meaning that if you run the same declarative template against the same environment multiple times, it won't change anything that already exists. It'll only make changes to things that don't exist that should or that are configured incorrectly and need to be altered. It's multi-provider, meaning that it's not just for Azure. The model for Terraform is that it has a whole bunch of different providers for Azure, for, am I allowed to say AWS? I'm going to say it. For AWS, it's got ones for DigitalOcean, it's got ones for VMware, a whole bunch of other providers. I forget, it's like 90-some different providers that it can connect into and do configuration against. So if you're in a situation where you want to configure something with multiple different providers, like say, a good example of that is I'm deploying stuff in Azure, but I want to use Datadog for some of the monitoring. There's a Datadog provider. I could do all of my configuration within Terraform rather than going to two different configuration sources. It is open source. If you are familiar with Golang and you want to contribute to Terraform or any of the providers that it hooks into, or write your own provider because you run a SaaS product or something, you can feel free to develop in Go and submit your changes through a pull request, or you could develop your own modules, and there is a sort of process by which they're accepted into the official, but you can't have like a beta provider that you've created on your own. Terraform is meant to be focused purpose, so it's not something that's going to do every single thing within your environment. It's not meant to control source code. It's not meant to be a deployment pipeline. It's not meant to do ongoing configuration management of your operating systems or applications. There are other products that do that, some which HashiCorp makes, but their whole idea is take the Linux ethos of a single focused purpose behind a product and stick to that. How does it actually work? So let's get into the meat of the product. So within your Terraform configuration, you define a number of different things. The first one is variables. So those would be the equivalent of parameters if you're using ARM templates. And then you say which providers you want to use, and within those providers you can consume data sources. So think of data sources as I need information from that provider to do something, and resources are things you're going to provision within that provider. So in the world of Azure, a data source could be I need a list of all the available SKUs within this region for VMs. And then I'm going to, in my resource, consume those SKUs and go deploy a virtual machine using the latest build of Windows Server 2019, which is apparently back in the marketplace as of today-ish. Once I've created all these different things within the configuration file, I put it through its paces in Terraform, and Terraform will give me a set of outputs that I define. What information do I want out of my configuration? It will save my configuration, the end result of what it did, into a state file that it can then reference later. And it also provisions the actual resources, which is the thing you wanted in the first place. The workflow for this is, first you invoke Terraform with the initialization command. And initialization allows it to pull down the provider bits. So Terraform by itself is a very small standalone executable. I think it's well under 100 meg. So it doesn't have all the providers preloaded in it. So part of the initialization is it looks at what providers you're asking for and downloads them from an online source. Or you can specify a local source that has those provider bits if you don't want it to hit the internet. It also sets up the state file, whether that state file is going to reside locally on your file system or you want to put that state file in a remote location, which generally you want to do. Then, once it's initialized everything, it gets into Terraform Plan, and this is where it looks at the current state of your environment and the configuration you've defined and says, what do I have to do to make the current state of the environment look like what I have in my configuration? And then it tells you exactly what it's going to do in a plan. If that plan looks good to you, you do Terraform Apply, and it does what it says is in the plan and creates all those resources. If you're done with whatever environment you created with Terraform, you can issue Terraform Destroy, and it tears the whole thing back down. So this is really good for if you want to rapidly deploy additional environments for a development situation or something like that. You could quickly spin them up and then quickly tear them down. Imagine Terraform Destroy is kind of a powerful thing to have available at your fingertips. So it does prompt you before it'll actually do the destruction, are you sure? And you have to type in yes, why yes, or it won't do it. So proceed with caution. In the world of Terraform Enterprise, that is a role that you can assign to a very specific set of individuals that no one else can run the destroy. So let's actually do a demo. That's enough of me yapping on through slides. So I use Visual Studio Code. Hopefully that's big enough. Yeah, it looks pretty good. So I have this is the first demo, I have some variables called out. So because I'm using Azure, I need to provide it with some information in terms of what region I want to use, what resource group I want to use for the deployment of my resources, what subscription. The app ID is basically your service principal that's going to be used to take these actions. The tenant refers to the Azure AD tenant in which your subscription resides, and the password is whatever password corresponds to that service principal. In providers, I'm just telling it I want to use the Azure RM provider, and then I'm giving it the information that I wanted to. One thing you notice is this is in a language called HashiCorp configuration language. It's very similar to JSON, but it's not quite as restrictive. It's a little more free-form, so it won't punish you. Well, I mean, you still have to close quotes and do all that, but if anybody's ever tried to hand edit JSON, it's not a whole lot of fun, and if you miss a comma or a bracket somewhere, even the best code editors can't always trace back exactly where you missed that, so sometimes it's painful. This is far less painful in that regard. So the way that this, the syntax works here is for the provider, I'm saying I want a provider. This is the type of the provider, and then I'm giving it a set of properties. So each property is laid out in the documentation, and then along with that property, I want to give it a variable I've defined before. So this $sign with the curly braces is what they call an interpolation. So it says this is a special value, and then what special value are you looking for? I'm looking for var, so that's the variable, and then what's the name of the variable that I want to look at. So that's what I'm doing through the provider section. I'm not pulling any data sources for this, so let's look at what I'm actually creating. So in here, I'm creating a resource. The resource kind is the Azure RM resource group. If you decide to use VS Code, if you put in the resource type and tap on the link, and I switch over to my browser, it actually takes you directly to the documentation page for that resource, and you can see an example of how it's used, as well as what attributes and arguments are available for that particular resource type. So it's very easy to, as long as you know the name of the resource, it's very easy to get some documentation around how am I supposed to use that resource. So in this case, I've already defined a resource group name in the variable. I've already defined a region, and I'm giving it a tag. I'm calling it environment demo. And then within that resource group, I'm going to create an Azure container group. Now, because I've created the resource group a little higher up, I can reference that resource group below in this resource. So by saying Azure RM resource group, the name of the resource group that I gave it up here, so see I gave it a name, demo, I'm referencing that down here, and then a property of that resource group is its location and its name. So I'm feeding that back into the properties. And in that way, Terraform creates a dependency graph, so it knows that it has to create the resource group before it creates the container group. Otherwise, it wouldn't be able to reference these values within the container group. And then there's just some other settings in here. At the end of it, it should deploy the Azure Container Image Hello World. And for the output, I'm asking it to get the property of the fully qualified domain name of that container group, tack on http://whack-whack, and give me that as an output so I can click on it and see what is actually deployed. So I do have a quick list of commands here because I can't type to save my life. So we'll run first the Terraform Initialization, and I should probably be doing it. Let's try that again. All right, so it looks for the plugins. That would be the Azure RM plugin. And it found version 1.18 and downloaded it. So that is all set and ready to go. The next thing we're going to run is the Terraform plan. And what I'm doing here is I'm running plan, and I'm passing in a file that has
the values I want to use for those variables that I submitted. So the variables in the demo file, if I scroll up a little bit, some of them have default values, so if I don't specify a value, it'll just use that default value. The ones that don't have a value specified, I have to specify a value for that variable either through the command line or by passing it a file that has those values already loaded in it. And since I don't want to expose my app ID and password, I'm using a file. Go. The dash out of that command takes the plan that I created and puts it in a plan file, which then the apply portion of Terraform can use. Like I said, when you run plan, it tells you what it's going to create. So if I scroll up a little bit, it's telling me it's going to create two things. It's going to create this Azure Container Group. The little green plus sign means create. And it's going to create the resource group. And it's not going to change anything or destroy anything. So if everything looks good, the next stage is for me to run Terraform Apply and pass it that plan file that it just created. I'll hit enter.
Did you have to load the Terraform modules, within your PowerShell session?
It's in the path variable, so I don't have to directly do that. The installation directory where Terraform is, I already have that in my path, so I can just say Terraform without an executable. But you're right, yeah, if you haven't done that. I installed it with Chocolatey, and Chocolatey puts it in the path for you.
Okay.
It's very kind of it to do. All right, so it did drop out that fully qualified domain. And there we go. assuming that it loads in something in a realistic time frame. This hung on me last time. Oh, I'm not gonna. It'll load eventually. All right. So that's a basic demo of running a Terraform configuration and deploying a simple resource. Sometimes DNS takes a little while to propagate, so I'm not going to worry about that. So what are the best practices around using Terraform? The first is, if you're a developer, you know, store things in source control. Well, since Terraform is all code, store it in some kind of source control and version it. Use remote state. So if I can just jump back to here, you'll see one of the files over here it created was this Terraform TF state file. And this defines everything that it created within the environment. So it can use this to reference back what's the current state of the environment. If I update the configuration and run another plan, it'll look at the state file and my configuration and decide what's different about those two and what do I need to change to bring the two in line. If you're just working by yourself on one desktop or laptop, you can keep the state file local. That's not a big deal. If you start working in a team or you work across multiple devices or something like that, it's best to put the state file in a remote location. There's a number of different supported what they call backends to host that state file. In Azure, you can just use Azure Blob Storage and it'll create a state file and host it there. You can also use like an NFS share or there's a couple different options. HashiCorp has their own one using their product console. But in this case, for the next example, I'm going to use Azure Blob Storage for that. There's also a concept of workspaces. So that state file is for the default workspace, but I can create multiple workspaces and each workspace is going to get its own state file. So if I want to create a development 1 environment and a development 2 and a development 3, I can just create a different workspace for each of those environments and run through the same Terraform commands. And because it's a different state file, it's going to deploy a new environment for each one. Now, of course, you have to make sure that your configuration supports that sort of idea. So you'd want to create a new resource group for each of those, maybe using the workspace's name as part of that resource group name, so you're not deploying over top of your existing stuff. But using workspaces for different environments, you can use that for multiple dev or dev, QA, stage, and production. And that way you can use the same configuration to deploy all the different versions of your environment. There is a concept called modules in Terraform, and so modules are basically a prepackaged configuration somebody came up with to deploy a commonly used set of resources. So a good example would be virtual networks in Azure. That's a pretty common thing. People deploy virtual networks all the time. No reason to reinvent the wheel. You can pull down the virtual network module that is maintained by Azure, well, not Azure itself, but maintained by some people who work for Microsoft on the Azure team, and know that it's going to pretty consistently deploy a VNet with best practices. And then the last thing is to separate out your configurations by workloads. So some people try to go whole hog with Terraform and deploy everything within one configuration. So all of my networking, all of my compute, all of my application, my DNS, and like 12 other things all in the same configuration. That can get pretty hairy when you want to try to debug it. That can get difficult when you want to update it, and it's not really modular in the sense that you can't just take up one component and put it in another configuration. So the better practice is to separate out your configuration. This is my networking configuration, and I can deploy that in any region. And then these are my 3 different applications I need to deploy. So I have a configuration for each of those, and I can pick and choose where I want to deploy that application. And I can use that on top of an existing network configuration. So for the second demo, I'm going to use the Azure Virtual Networking module. I'm going to use a remote networking state, and we're going to deploy an Azure VNet. And ooh, it did finally load. There's my Azure Container instance. Yay! Okay, so let's go into demo 2. Pull this stuff out. All right, so demo 2. The way that Terraform looks for the configurations, it looks for any TF files in the folder that you're currently working in. So you can actually break out the various portions of your configuration into their own files, and that can actually be a little easier sometimes. If you have a common set of variables you use it across multiple configurations, you can now just take that variables file and copy it into any directory that you need to use it in.
Extension code that gives icons.
Yeah. So there is a Terraform extension for code that'll suggest you install if you start dealing with TF files, or you can, do it ahead of time. Thank you. Good question. So just to get an idea of, actually, we'll start with the back end. So the back end file is defining where I want to store my remote state. And so I'm giving it some information here. The backend type I want to use is the Azure backend. Here's my storage account name. Here's my container name. Here's the key, which is the file I want to store my remote state in. And then here's the resource group name in which that storage account exists. So I already set all of that up separately, and it's just sitting and waiting for me to use. You notice I didn't specify any access key for the storage account or any sort of authentication information. I've actually got that information stored in environment variables, so I don't have to specify it in the command, so you don't have to see the password and I don't have to change it later. But I've included in here, up in the setup, if you were going to run through this, if you run this PowerShell script, it'll prompt you for all these values and put them in environment variables for you. That's the back end. In terms of resources, what are we actually deploying here? So we're using the module keyword, and we're calling the module VNet. And the source, we're telling it to get it from the Azure Network Azure RM. And there's an online registry. It's registry.terraform.io. If you don't specify a full path, it assumes you're using that registry and will just look for this in that registry. If you wanted to specify your own custom source for a module, you can do that. It can be a local file, it can be a file share, or it could be a website where you've hosted those files. All of the modules are open source and on GitHub, and actually I found an issue yesterday when I was building this demo, so I got to fix it and set a pull request, which hasn't been accepted yet, so you get to see that live. And then I'm just giving it some default settings that it wants as part of provisioning the virtual network. So it wants to know what resource group, what's the name of the virtual network, where am I spinning it up, what's the IP address space to use, what are the subnet prefixes, so those are the IP address spaces for each subnet, and then the names of the subnets. So I'm giving it all that information, and then I'm also specifying some outputs in here. And the modules expose outputs that you can use within the rest of your configuration, but you can also output them here. If you want to reference this remote state in a separate Terraform configuration, you have to expose the values as outputs in this configuration. So that's what I'm doing. I'm going to use these values in the next portion of the demo. So I'm exposing the virtual network name, the virtual network ID, and the first subnet's ID. Okay, so hopefully that makes a decent amount of sense. Feel free to interrupt me with questions. All right, so
When you say expose,
mm-hmm.
well, okay, let me go back. Okay, okay, like you're gonna run that like .tf, right?
Yep.
So it's Terraform dash file name .tf, or is there only one TF file in that directory?
So in this directory, if I just do a quick ls, you'll see there's multiple TF files.
Mm-hmm.
And so when I run the first Terraform Initialization command, I'm not directly referencing any of those TF files. It just assumes that since I'm running it in this directory, all these TF files together make a full configuration.
Okay.
Which makes those individual TF files reusable. So the backend, for instance, I might use the Azure backend for multiple different things, multiple configurations. So I can just copy that backend file to another directory and know that I've already at least got the basic configuration down right for that back end.
Does a Terraform know that, you know, like you have the 5 files, whatever,
Mm-hmm.
that it's going to scan through them all, it's going to find your variables first, right? And then, for example, it's going to create a VNet, a VM, a public IP. Does the Terraform itself know, oh, I have to do it like in this order? Or like you can specify here to name 1.tf first, name 2.tf second, or does it know?
It
with
knows to
some kind of
take.
intelligence. You have to have a resource group first.
Yes.
Okay, then your VNet. Okay, then your NIC. Okay, then your VM.
So it creates a dependency graph based on how you're referring to different resources.
Okay, you
so
don't do that. This does it.
This does it.
Okay.
It does its best. So if I have a resource group and then the next resource I reference that resource group, it knows when it builds its dependency graph, okay, I have to create the resource group first before I can create a resource inside it. I have run into situations where the two resources are not obviously related, even though through some application logic they are. So Terraform doesn't know that, so there is a depends on property you can specify in a resource and make it dependent on another resource before it'll create that one. And so Terraform will take that into account.
So some of them have the intelligence that they know what the dependencies are, and some you have to explicitly state.
Yeah, and the vast majority of them that I've dealt with can figure it out based on dependencies. It's few and far between where I have something where it won't do that. One example that I did for a demo a couple months ago was I was building a VPN between an AWS VPC and an Azure VNet. And so this gateway had to be up before I built this virtual machine to connect to it. Terraform had no idea because there's no real dependency there. So I had to put an explicit depends on so that it would know to wait until that gateway's up to try to create the VPN connection. So that was kind of a weirder situation.
Makes sense. It mentioned that it'll utilize all the TFs that are in the same directory.
Mm-hmm.
Are you able to reference something into another directory if you wanted to organize them? What you described as your one reusable, like VNet. And you had to copy it in each directory.
That would be more of a modules situation. Okay. So one of the modules you could be referring to could be a subdirectory of your existing configuration. And that's why I said, like, if you're building configurations, it's best to kind of chop them into digestible chunks as opposed to having all these different configuration files and end up with a real mess of code. So if I run initialization, because I'm using a module and it's at that registry, it's going up to the registry in Terraform and pulling down that module. And what does that actually mean? It created this .terraform directory, and within that .terraform directory, there's now a modules directory that has this module with this crazy name. But if I actually expand this, it'll tell me this is the Azure Terraform Azure RM networking module, and it has all of the information in here. So if I want to look at what it's actually doing, it's all in there. And unless you explicitly tell it to, it's not going to download that module again. Once it's downloaded, that's the actual files it's going to use to build that configuration. Yes, it also downloaded it creates a plugins directory, and that plugins directory has the Terraform provider executable in there. That's the actual Azure RM executable that's publicly available. You see, it pulled down version 1.18. If for some reason you wanted to stay 1 or 2 revs behind on the provider, you didn't necessarily want to be on the cutting edge of what they consider stable, you can download these providers and put them in a directory and then tell Terraform to use the providers in the directory as opposed to pulling them down. So that's not uncommon. Or you can specify which version of the provider you want to use directly. So it depends on what security model and what stability model you want to use. If you just don't want to provide internet access to whatever's running Terraform, you could also download those modules and plugins locally. Let me get this kicked off. Can't type today. All right, so I'm just going to create the out file and call that to demo TF plan.
So you put all of the needed variables in that additional file.
Yes.
Okay, so when you need Terraform, it knows, okay, whatever variable you see in the .tf, it better be in that.
Right.
Is it TF or TFVars?
TFVars.
Okay.
You don't have to call it that. It could be .json or .txt,
okay.
But the actual file itself is just the name of the variable equals whatever the value is in quotes. That's all that's in that file. And it does have a preferential order, so the first preference is use the default. But if you specify a variable file, it'll use that value. But you can also specify a variable inline. So it'll use the inline over the one that's in the file. So you can sort of override yourself multiple times. I wouldn't try to get too fancy on that, but it is possible to do. All right, so that is refreshing the state and telling me, all right, I'm going to add 5 new resources, which is the virtual network and the subnets in the virtual network and the resource group. So that's all the stuff it's going to create. If that looks good to me, I'll run the plan. I'll run the apply command, and that'll actually go and now create these resources. While that's creating, we can jump over in the portal, go to my resource groups, and I'm going to find that storage account that I created. So this is the remote state account. And it's in blobs. There's the container that has all of my remote states for the demos. And right now it's updating this to.demo.state file. Because you're using a remote state file, if someone else was working on this same environment, this same configuration, and they tried to make a change to this environment, first thing Terraform would do is try to go get a lock on that state file and realize somebody else is currently using it, and tell you can't make any updates until they've released the lock on the state file.
How'd you get that state file in here again?
So when
Is that done with the Terraform, or
yes,
is it something you did?
I created the storage account and the container, but the actual that actual state file in the back end configuration is, I said that I wanted to use Azure RM, and I gave it all the information about where to place it. Okay. Including the key. So the key corresponds to the actual
configuration.
file.
You're putting that state in there, so the next person to run this, as long as they have that identical, okay, it's going to know.
It's going to know that's where the remote state lives.
Okay.
So before I do anything, I'm going to check in with that remote state and make sure I can get a lock on it. So yeah, now it's created all these resources and all the outputs that I asked it to dole out for me. And if I click this state file and if I do download, this is the actual state file where it has all the information of what it just created, and it'll reference back to this. That's demo 2. Demo 3, we get a little more complicated. So I am going to use the Azure Load Balancer module and the Azure Virtual Machine Scale Set module, along with the Terraform configuration files. And then I'm actually going to go look at the state file from demo 2 and pull network information about that, because I want to put that I want to put the virtual machine scale set in a subnet. So I'm going to pull the name of that subnet ID out of the network state and create the load balancer and scale set within the virtual network, and then write out what I just configured into a new state file that could be consumed by something else. Let me close at least some of these files to make it a little easier. There we go. All right, getting into the wonderful world of this. So 3 demo in resources. So how am I getting that information out of that other remote state? So in here in resources, I've specified a data source. That data source is of the type Terraform remote state. And I'm just giving it a referenceable name, 2-demo. And I'm saying, okay, the remote state is Azure RM. here's the configuration information you need to know about accessing that remote state of the other configuration so that you can get some values out of it. That's how I'm pulling the information from that other remote state. And how do I refer to that information? So if I scroll all the way down to where I want to get the subnet ID for my virtual machine scale set, I say data, Terraform remote state, that 2-demo, and then which property out of that remote state do I want information on. And since one of the outputs of the second demo was subnet 1, I can reference that output here as a value to use when I use the remote state as a data source. Anything of interesting? I have some outputs. Like I said, I am using modules again. So this module is the VMSS Cloud Init module, and this is the load balancer module. So I didn't have to write all the stuff that goes into creating a virtual machine scale set with a cloud config file. I didn't have to write everything that goes into what needs to be in a load balancer. I'm just consuming the work that somebody else created with these different modules that exist. All right. So,
are these modules Terraform modules, or are they supplied by else?
They're supplied by whoever wrote them, and generally speaking, at least the Microsoft and AWS ones are written by people at those respective companies. I think to get into the official Terraform modules registry, you have to pass a certain number of tests that they lay out for you. So you can't just willy-nilly say, here's my module, put it in your registry. You have to be a little more procedural about it.
Right.
So generally, if it's in the registry for Terraform, it's pretty safe to use. It is, open source. You can go and open and see what it's doing.
That's what all PowerShell for the Azure modules.
No.
What, really?
Well, so the actual modules themselves are basically just
They armed them.
no, they're just more Terraform. Terraform, it's turtles all the way down, I'm telling you. Well, let me run the initialization and you'll see exactly what I'm talking about. Because actually I'm gonna have to go in and edit one of them. So when you download those modules, it creates that .terraform file. And so here's one of the here's all the different modules. And let's find the virtual machine scale set. So that's this one. And so this is an exact copy of what's on GitHub for that module. It's really just doing a GitHub pull of everything that's on GitHub. Some of this stuff is for the Travis CI. So this is how it does testing. If you check in a new version of the module, it builds in a Docker container some testing harnesses to actually test the module and make sure it does what it's supposed to do. But the main things that you're concerned with here are the .tf files. So main, tf, outputs, and variables. If we look at what's in there, main tf is just creating a whole bunch of resources based off of information that you've provided. So it's just Terraform .tf files that are building this resource. Now on the back end, what is it actually doing? It is eventually creating an ARM template in JSON that it submits to Azure Resource Manager to actually build that resource, but that's abstracted from you. It's using the Go SDK from Azure to build those templates and submit them out. Ray, why would you use this instead of an ARM template?
Yeah.
I mean, for me, the number one thing is ARM templates are in JSON, and I don't like hand editing JSON. So that's certainly part of it.
It's a better user experience.
I think it's a better user experience. The other main reason for me is I do a lot of cross-cloud work. So being able to just get really comfortable with one tool set makes my life a little easier. So whether I'm doing an AWS project or an Azure project, or God forbid I'm doing something with VMware, I at least have one single tool set that I can continuously refer back to and get really good at and apply that, instead of learning the weird nuances of CloudFormation or ARM templates or whatever the tool might be. Now, like I said, I found an issue with this module, and the issue is this. It's telling me that I didn't set a required field. That's because Azure changed the required fields for the virtual machine scale set, but no one updated this module yet to reflect that. So if I go all the way down into network profile, you now need to have this setting in your IP configuration. This took me about an hour and a half to figure out. Looks very simple now, right? Oh, you just put primary true. So because I've altered the module and it's not going to re-download it, if I run Terraform plan again, it's actually going to successfully run through the plan. So that's an example of what the errors look like. That pull request is in, so hopefully that gets accepted relatively soon. But so yeah, it's refreshing state, but I think it's adding a whole bunch of stuff. Yeah, there we go. So it adds 11 new things. I'll go ahead and kick that off. That's going to take a while because it is deploying a virtual machine scale set, so I don't think anybody wants to watch text scroll by for the next 3 minutes. We'll let it do its thing. So getting back to, there was a PowerPoint originally. So we successfully did our thing. We pulled information from a network state. We're writing out to a new remote state. Those resources are going to be deployed. What could I possibly do next? I'm going to make it more complicated. All of the examples that you've seen tonight are on my GitHub in a repository. And so for demo 4, what I wanted to do was connect to that GitHub repository. Almost out of time, aren't I?
Is Rudy here?
Okay. All right. I've got 7 minutes. All right. So I'm going to pull it from GitHub, and I'm going to have a Jenkins pipeline waiting to run my Terraform configuration. It's going to pull that network configuration and deploy an Azure VNet module and save it to a remote state file. Let's get as complicated as we possibly can, right? So hopefully within this time I can actually get this to work.
Question for you. After you've provisioned your compute, and you have providers plug in Chef Puppet or
So if you want to invoke something like Ansible, I guess there's a couple different ways to do it. When you provision a virtual machine, you can run a remote exec provisioner, which will run shell commands within that virtual machine. And so you could start, basically stage it for your next configuration.
okay, so you would hand it off. So we
Yeah.
would bootstrap our own VM tool. Some extra.
Exactly. Yeah, because Terraform's not a configuration management
Right,
tool,
right.
so
For
that's
people
really
who
where you
use
want to
this
hand it
probably
off.
have one, so you just have to get them.
Exactly. What am I doing? Jenkins is running on an Azure virtual machine, and I'm using the managed service identity property, so I don't actually have to specify Azure credentials. It's just using the managed service identity within Azure to do all of its work. And I totally forgot that I was going to need this. I don't even have this copied, do I? Time crunch. Where is that file? I guess to see a quick dive into my wonderful world. What happens when you run everything on a different desktop and then you decide, okay, now I'm going to run it from this laptop. Yes, that's fine. Okay, so now I need to. It doesn't expose Jenkins directly, so you have to SSH into it. And you're kind of doing an SSH proxy. I think and then there we go. Hopefully that works. No, didn't like that. Okay, so we'll try it this way. This one. Ian, all this happened live. Yes, fine. Okay, well, it would work in theory, but I don't want to go over my time. So let's see. It did. It successfully configured all of my virtual machine scale set, and I had it drop out an HTTP web address. So if you go to the load balancer, it now shows you what the configuration file did, as I had a cloud config in there that installed a basic lemp stack on Ubuntu. So it's just running, PHP and MySQL. So that's, knew I wasn't going to get to the last example. I had faith though. So if you want to learn more, a couple different ways to do it. You can go to the documentation. It's just terraform.io. There's a whole bunch of docs in there. They're fairly good, though sometimes they can be not as, they don't explain things as much as I think they should. So you're left to your own devices. As a matter of shameless self-promotion, I have 2 courses on Terraform on Pluralsight. So if you have a subscription, you can check out those courses. Or you can sign up for a trial and watch at least one of them during that time. There's also a really good Terraform book called Terraform Up and Running from O'Reilly. If you're a book type person, that's a good investment of money right there. And finally, like I said, all of the examples that were part of this, as well as some setup files, are on my GitHub. It's ned1313, and then the repository is Terraform-AZUG for Azure User Group -demo. So everything's checked into there. You can, fork it, copy it, whatever you want to do. Try out the examples. You're gonna have to tweak some settings in there, but that's pretty much it. Feel free to hit me up on Twitter if you have questions or run into issues running through some of these demos. It's ned1313 on Twitter. I pretty much try to use that everywhere, so it's fairly consistent. And with 2 minutes to spare, I'm done. Any other questions? No? Awesome. Thank you.
Quick announcement for everybody in here. The pizza is here, so if you want to head back through that door, it's in the servery. There's food and drink back there. Grab that. You're allowed to eat in this room. Grab what you want while we're switching speakers, and you can eat in here.
We're allowed to eat in this room?
In this room, not in the empty office. You can eat in this room. While
This room isn't as
Rudy is
nice.
getting set up to do the next session on Azure Security, so stick around.
Shabnet, thanks.
Thanks. I meant to get that Jenkins connection set up ahead of time because it's always a little finicky, and I just. How are you doing? Good. How you doing? Are you going to be diving into like Azure Security Center?
With 1 hour, it's not possible to go so deep. But
We'll show the page.
yeah.
And this is Security Center. Next thing.
But the idea is to cover maybe 90% what we have on security on Azure, just so that everyone can remind.
Okay.
And say, hey, I like that.
cool. We're back. Thanks everybody for sticking through. We now have Rudy from Microsoft giving us an overview of Microsoft Azure. Just once again, thank you to Ned for presenting at an excellent for sponsoring. Thank you, Ned. Rudy, sure. Floor is yours.
Yeah. Thank you everybody for your time here. Probably everyone has hours of work today, like me, like Rich, like everyone. So, but I'm very happy because it is the first time I'm going to talk to a group like that. So a little bit about my background quickly. I started with IT in 2003 at IBM. Maybe there are someone here that already worked for IBM. You always find someone that worked at IBM. So I spent maybe 10, 12 years there, and then I started working with the cloud at IBM with SoftLayer and Bluemix. And I've been working with cloud for 6 years. So from those 6 years, almost 4 years, I have spent working for Microsoft. I started work as a data solution architect, so I work a little bit with data, big data, and something like machine learning and stuff like that. So after 1 year work as a data solution architect, I started working with infrastructure, and then I still working with it. So I don't know if all of you agree with me, but maybe 10 years ago, when you talk to everyone and say I work with infrastructure, it basically you work with hardware. But today, when you mean infrastructure, you work with a lot of things. So infrastructure is regarding hardware, automation, networking, operating system, and there are some places that database is considered infrastructure. So there are some places that they are killing the DBA. So I don't know, it changes a little bit from company to company, but what I want to say in the end of the day that infrastructure can cover a lot of things, and especially with cloud computing, For public cloud computing, security has been very, very important. A little bit more than 1 year ago, I started working with financial customers. Is anyone here from financial company? Oh, great. And because of that, I got a lot of requirement to talk about security. So I end up focused on security because I started working with financial customers. So lucky me that I find a lot of financial customers, and that bring me to focus more on security and also keep my job with infrastructure. So that's my quick story. That's why I'm here. I'd like to make a quick question for you so that I can understand a bit about you. I'm not going to ask you the name of anyone, but just understand who work with Azure today. Just raise your hand, please. Oh, not so much people. Amazon? Google Cloud? Okay. Public cloud? Doesn't matter what? Okay, so the rest of the room, I believe, has a traditional environment, let's say like that. Kind of on-premise environment, a bunch of servers, database, etc., etc. Okay, guys. That must represent maybe 80, 90, 90% of the security on Azure. So I'm specifically about public Azure, just to remind that we can find a hardware, a kind of appliance called Azure Stack. I don't know if you all have heard about it. Some people say that it's a cloud on a box for on-premise environment. It's not much like that in my personal opinion, but here we are gonna talk about public cloud, specifically about public cloud. And of course, we don't have time to go into details for every single service, but instead of speaking with you, and I know that doesn't work so well about product and what it is, how it works, etc.
I prefer to put you in a real scenario that maybe 90% of the customer usually goes and usually work. And then we are going to explore security over those scenarios. So most of customer usually has an on-premise environment. That's the most case here. And by some reason, sometimes cost, sometimes automation, sometimes better process, I don't know, a lot of different reasons, decide to move to the cloud. So the first thing we should know it is that Azure, for every subscription on Azure, and subscription here means a logical container environment that you create a lot of resources like VMs, storage, database, etc. Has an Azure Active Directory. Why not an Active Directory? Like probably most of you should have, or all of you. Active Directory, like you know, in our on-premise environment, usually work with Kerberos for authentication and LDAP protocol. Azure Active Directory work with SAML and OAuth for authentication. So it is different protocols, and usually what most customer does is getting their Active Directory and sync with Azure Active Directory. The great reason to do that is because you don't need to manage users here and here. So you can synchronize your Active Directory with Azure Active Directory. Again, every time you start with Azure, by default, you already have an Azure Active Directory. By a simple reason that Azure just work with SAML and OAuth. So if you want to sync again, you can do it, and you can manage all your users for Azure from a single point of control. Okay.
Quick question.
Yes?
So if we're already a 365 customer, we already have Azure AD, would we be synchronized when we start to consume Azure resources and build resources out there? Will we be using the same Azure AD instance, or would it be a separate Azure AD for infrastructure as services?
Got it. That's a great question. We have 3 boxes here in the screen. On premises, Azure and Internet. I don't know if every one of you knows, but when you have a O365, you have an Azure Active Directory for it. And of course, it is in somewhere that you don't know. That's why I'm going to represent here on Internet. And what you can do when you use an O365 on the cloud, you can do something like that. You can synchronize your on-premise Active Directory for the O365, and then you can point out your O365 for Azure. So you just need to do that once, and here you just need to say, I want to use my current O365 Azure Active Directory.
So it's, in a sense, it's so two separate. There's O365 and Azure of 2 Active Directory.
No, you don't have 2. You just going to have 1. What you're gonna do is to say for Azure, please use my current O365.
Okay.
So in the end of the day, what I mean, that will not exist anymore.
Okay.
I mean, will exist, but you're going to point out for the O365. Yeah. Most of customer does that integration usually when already use the O365. Very nice question. So yeah, So when you decide to go to Azure, that's the start point scenario that you have. And I just move a little bit here because I just want to comment that you have many ways to move into Azure. So you can basically go to a lift and shift migration. I mean, the way you run today, you're gonna run on Azure. No big changes, no modernization like some people like to call, no re-architecting, no refactoring, no recode. Just to provide you some examples, what I mean here. Let's say you run your environment in a bunch of VMs and you decided that because you're gonna move to Azure, you want to change, instead of using VMs, you're gonna use containers. In other cases, instead of using containers, you want to move directly to microservices. That's a big change. Usually almost no customer does that because there are a lot of risks. What most customer does, it is working phases. So let's move what is easy, there is no critical, as a lift and shift. And then let's say web servers, for example, that is very simple usually. Let's re-architect that, and instead of use VMs, let's use a platform as a service. So just to comment that sometimes you have different ways to move to the cloud. So coming back here, just to continue the story, the real story of most of customers, the next step would be how I'm gonna move my data into the Azure, because I don't know, maybe you have 1 terabyte of data to move to the Azure, maybe you have 100 terabytes, maybe you have 1 petabyte. So you have a lot of ways to do that in a safe way, and I'm gonna talk to you about that. The next step, it is create your VNet, what we call VNet. Some people that know Amazon are using with this as VPC. I don't know if exactly I can compare with a Vlan, but you can understand VNet on Azure as a network perimeter that you are completely isolated by other customers. So it is a logical implementation based on layer 3. When you see for OSI model for network, on top of a software-defined network on Azure. But yes, Microsoft guarantee that you are completely isolated from other customers.
So regarding the right of dev, QA, will separate VNets for each environment with practice, or?
Yeah, there are different ways to accomplish that that you just mentioned. You could have one VNet and multiple subnets, or you could have multiple VNets and work with what usually network engineer call hub-spoken topology. I mean, you selected a VNet with multiple services like security service, Active Directory, and for other VNets, you don't have any special service. You just connect on this VNet called hub. So in that way, you can segregate it by VNet and still using a lot of services. That's I would not say a best practice, because sometimes you can use only one VNet with multiple subnet, and that's enough for your environment. Because when you have multiple VNets and you need to make them talk to each other, you're gonna pay for something that we call in Azure VNet peering. So inside the same region, it is about 1 cent per gigabyte. Maybe you think it's not too much, but I don't know. Sometimes we have application talk to database and exchange a lot of data. So monthly, 1 cent per gigabyte can be much or not. So, but it's a good point of decision if you are gonna run one VNet, multiple subnets, or multiple VNets.
Sorry, but you're talking about the cost of traffic over the network peering? versus if you have, I think what the question was, if your whole environment is in that one VNet, there's no cost there, just communication with whatever's in that.
No,
right?
inside a single VNet you have no cost. But yet you can segregate using only subnets. That's the great point that you take into consideration.
Usually what
Yeah. And I'm gonna talk a little bit about how to secure a subnet. And then the next step should be create your VMs. Of course, this is a typical infrastructure environment with no platform as a service yet, at least on my diagram. Of course, you're gonna have to consider backup, and then you're done. You're good to get your internet users. Let's say if you have an e-commerce or if you have your administrators outside the company trying to connect on Azure, that's the diagram, that's the solution design you're gonna need. So let's apply some security services on that environment, and I'm gonna explain one by one for you. Again, that's just a macro overview because of course we have just 1 hour. We had 1 hour. Now we should have, I don't know, 40 minutes. My gosh. So let's run. One thing that you can do it is protect your VMs, your Windows servers with any malware solution. That's based on Windows Defender. You can go to the portal Azure and in a graphical interface, you just give one click and you have implemented that on Windows VMs. We don't have any malware for Linux servers. You have to consider whatever product you want from the Linux world, but for Windows, it is red just to be selected and use it. The next important secure thing here it is that you can encrypt your VM disk. Very good information here. It is the VM disk relies on a storage layer on Azure that is transparent for you. You don't touch. You don't select arrays like you do in your on-premise environment. You don't select what is the RAID protection you're gonna use. You simply says to Azure, I need 1,000 IOPS, I need 5,000 IOPS, I need 100,000 IOPS, and you're gonna have those disks for you. So this storage layer is already encrypted for you. You don't have to do anything. It's already encrypted based on a synchronous key of 256 bit, based on pattern AES. But let's say that you have to copy a folder or a file or a bunch of files for someone, and you go into the Azure operating system of your VM and copy those files or folder. They are not protected. But something that is practically impossible, someone go to Azure Data Center and steal some hard disks. That is impossible, but let's say the data is encrypted. Is it clear? So based on that, you can encrypt your VM disk. So you are gonna have encryption over encryption. That is okay. You can use BitLocker for Windows Server and the Encrypt for Linux servers. Okay. About moving data into Azure, again, if you are going to move, I don't know, 1 tera of data, you can go online and safely move those data encrypted by using some tools from Azure, like Azure Storage Explorer, that is free of cost. But if you have a huge volume of data, you can use some other stuffs like something called Databox, that you can move up to 80 terabytes, or another Databox that you can move up to 1 petabyte. And that's very easily. I'm gonna provide you some information about costs so that you can have an idea. If you want to move 80 80 terabytes, you're gonna pay $600, including ship to Azure. You just make the request in the Azure portal. You're gonna receive in your data center a box like 7U of a rack unit, and then you're gonna have 10 days to put all your data inside it, and those data is encrypted as well. And through UPS, those devices, or this device, is going to be sending to Azure, and someone on Azure is going to put all those data on a storage account for you, and you are ready to complete your tasks that you have to have your environment running. So it is very easy, and you don't spend so much money. Another good thing that you can use about security is consider multiple factor authentication. So if you want to use a cell phone, you can, so that you can increase your security for your users. Something interesting that you should know here, it is that let's say you have a user here in your AD that is a global admin. When you select this user, let's give a name here, John. When you use John as a user for the Azure, he can have different roles. So again, he could be a global admin here for Active Directory perspective, but for Azure, he can be a reader, for example. I mean, a role that you can just read resources. And the opposite is always true. You can have a simple user in your Active Directory, but it can be a super user here on Azure that we call owner. So we have three types of roles on Azure. It is the owner, the contributor, and the reader. The difference from the owner for the contributor, it is basically that the owner can create new users and the contributor cannot do that. But both of them can do everything on Azure. But we still have a very good granularity here, because Azure has a hierarchy here. So we have the subscription. Under subscription, we have something called resource group. And under the resource group, we have the resources itself. So those resources can be, again, a VM, a disk, a storage account, a DB, etc. If you say that a user is going to be granted access to the subscription, these users can do everything under the subscription. But you can get this user and say, okay, you are just going to control one single VM. So when this user connects on Azure, you see only this VM, only that resource that you provide access. So it is very nice, and we call this granularity and flexibility as RBAC. I mean, role-based access control. Just an acronym, another one. So how to connect the Azure environment into your data center? We have some ways. We can go and connect through the internet with no security. Of course, most of customers don't do that, but you still can. But you can use VPN, and of course, for VPN, you're gonna use an internet service provider. And with VPN, you're gonna exchange the data by using IPsec as protection, and you can work with speed, I mean bandwidth, starting with 100 megabits per second, and you can have even 20 gigabits per second with VPN. So that's one option. The second option is called Express Route. Here you don't use internet service provider. You can connect your environment, your data center, straight in the Azure through some companies that we call Extended Cloud Provider. Equinix is a great example, because they have a lot of data center in US, and usually what happens is a a telecommunication company that we call here as a connectivity provider should connect your routers into the Equinix routers, and Equinix routers are connected to Azure router. You're never connected directly into Azure. You should pass through Equinix or other company that is classified as extended cloud provider. So some curiosities here. This tunnel is not protected. So I mean, it is protected somehow because you're not going to the internet. But if you want to exchange the data, for example, through IPsec, you can put a VPN inside ExpressRoute. Or if you have an application that talks to a database, or with another application from your premise environment to Azure that talk HTTPS, you are already protected as well. So it depends only about your solution design and how you want to accomplish security here. For ExpressRoute, you can start with 50 megabits per second, and we can have up to 100 gigabits per second. Of course, the more bandwidth you want, the more expensive it's gonna cost.
Is it, what about VPN? Is that same cost? Is it 20 GB?
No, completely different. VPN is, let's say, much cheaper than ExpressRoute.
How much is the cheap express route?
Yeah, we can take a look at, but ExpressRoute, you're gonna have costs with Azure, with the extended cloud provider, and with your connectivity provider. It is 3 costs, and 2 of those costs is not regarding to Microsoft, so you have to manage that. VPN is Azure product, so you don't have any other third-party vendor involved. But again, it depends on what you need, what you want.
A question going back to the security and the user accounts. Is it a best? I know that you can create Azure accounts directly, but is it a best practice to really synchronize them from your on-premise AD and grant role-based access that way? That way, that when your automated provisioning, deprovisioning practices, when folks separate from the company, are automatically removed. Otherwise, they could remotely connect directly. If you don't get rid of that account. So is it a good best practice to sort of use your on-premise identities and synchronize them to Azure AD and grant them the appropriate access in Azure?
Yes, for sure. But again, you have a cost for that. And another great reason to use ExpressRoute, it is when you want to extend your Vlan to Azure. So let's say a very good example. There are some customers that use it.
My question was about security versus performance and cost. It was about managing the users and what they can do in Azure.
Because they'd be synchronizing to Azure AD.
Yeah.
You're in full control of your on-prem AD, and somebody gets terminated.
Yeah.
You cut them off. Synchronization takes place, and now they're out of Azure AD as well.
The sync engine has certain things that it'll do an immediate sync on,
Yeah.
password change, and disable user or something.
That's it.
I know, because I know we have like Azure accounts directly, and they're powerful, and you can lose control of them real quick.
Yeah, I got it. Yeah. Let's say you start a new company and you rely only on applications on Azure. You don't need an Active Directory. You definitely can use all users managed by Azure Active Directory. The great point about synchronization is when you have services on premises that you need to keep relying on Active Directory on premises, but you don't want to manage 2 different Active Directories, so you can do that synchronized. But
so to answer your question, yes.
Thank you, buddy. Yeah. So the next point here about security is that we can use something called Network Security Group. That's free of cost. it is very powerful because that's a kind of a packet filter based on TCP UDP, and you can filter those subnets based on IP range and port range. So a very typical example, let's say you want that subnet database will just accept incoming packs from the subnet call application. You can do that simply with network security group. And the same for the other two subnets. You can tell to the subnet call application that only the subnet call front end it's going to request any kind of information for that subnet. In that way, you make that the front end subnet cannot go and talk to the subnet called DB. So this is very powerful. You don't have to manage infrastructure, you don't have to manage your hardware, you don't have to manage high availability, scalability. It is there, it's just configure and use it. If you go to security books, most of them will always says to you that the more layers, the more protection layers you have, the safer you are gonna be. Of course, you're never gonna be 100% safe, right? If anyone here already watched Mr. Robo, I remember a great sentence that says, "You want to be protected, turn it off." But as we cannot turn it off, the more layers of protection you have, the safer you are. So you can have a lot of layers here, and one layer that you can have could be a DMZ, as someone like to call, with a web application firewall, or with a bunch of IDP, IDS appliances. So on Azure, you can go to the marketplace and you can choose a great list of appliances, like the most famous one in the market, like Barracuda, Palo Alto, Private Checkpoint, F5. There's a big list, and you can simply choose one and use here. Just an important point, all of those are virtual appliances, not a physical appliance, okay? So you have to deploy those one on VMs, and you have to set up for the redundancy you need, but it is there. If you are, I don't know, accustomed to use a F5, you can go and choose an F5 and continue using on cloud. Another layer that you can add here, it is a DDoS protection. It's not all appliances like IDP, IDS that can understand when you are suffering a DDoS attack. I don't know, like a ICMP flood, a SYN flood, or TCP flood, whatever. So we can plug a DDoS protection in Azure. That's a Microsoft service. It's not a third-party vendor, but you can definitely plug a DDoS protection in a web application firewall that is connected on network security group, and have all those layers working together for your security.
Question.
Yes.
Do you recommend a security appliance between the subnets to protect them, or can you simply use a network security group to protect the traffic?
Great question. Let me show you.
Obviously, the caliber of what you're going to get with a network security group is not the same that you would with an appliance.
Oh yeah. Let me get here. Let me remember. I think there's a good example too. Anything you want, guys. I put my mail here. I can share with you. Okay, those examples, any information. Feel free to write me. What you all can see here. That big box here, it is Azure. Just so that you can understand this diagram. This one, it is your on-premise environment. This other box, it is the VNet. It is the VNet. And those white box are subnets, different subnets. You can see here that we have two DMZs. One DMZ with policies for who is on internet, and another DMZ with policies for who it is on your on-premise environment. So, by answering your question, the DMZ, it is a subnet. And what you can do, it is use appliances or Microsoft Azure services that will connect one subnet with other. In this case, I have here until, I still have here a subnet with a route table that I can specify a lot of rules by telling, for example, non-pack goes from web tier straight to internet, just an example. But every request that should come back to the user, it should go first for my on-premise environment and then goes to the user. Just an additional example of what you can do with route tables and also using DMZs. But just to make clear, the DMZ resides on a subnet, okay? And you can, of course, interface this subnet with the other subnet by using network security groups. Okay, guys?
Relating an air gap node and creating the DMZ from a load balancer, they can talk to my.
Gotcha. Good question as well. The load balancing, it is here, and that's the integration with the subnets. Let's say again here in the right side, I have a cluster of database VMs. Here I have a cluster of application VMs, and here a cluster of front-end servers VMs. Let's forget about here, but let's say that we have internet and user here. That's the load balancer. The user is going to connect here. So the load balancer is going to reside inside a subnet. And this is a L4 load balancer. There can be used with up to 1,000 of VMs. 2 or more up to 1,000, and then it balances for you accordingly with the rules that you set up for that. And when this subnet has to pass the incoming request for the next subnet, it can go to another load balancer, and then that's what happened. And then again for the database tier, the application tier talked to the load balancer for the database tier, and then got the request, and everyone come back to the user by using the same model. That's where the load balancing resides, and you can still use and consider another load balancing of layer 7 that you can balance it based on an HTTP or HTTPS. I mean, the application layer, not the TCP. Yeah, the application gateway. It is a service called application gateway. That's again, it is an Azure service.
And for public facing like the front.
It comes right here. You can also use a CDN. Yes, that's it. Good point. You can get a service on Azure like Storage or like a platform as a service that run your front-end servers and point to a CDN that can be an Akamai, a Verizon, or I don't know if all of you have heard, or a Microsoft CDN. Now Microsoft is using their point of presence to act and work as a CDN. That's another choice. You can have it. I don't know currently, but a couple of months ago we got almost a half of the price from Akamai and Verizon with Microsoft CDN. So just to have in mind, I know you have CDNs like Cloudflare with a good price, but again, you can have in mind that you can consider Microsoft as well. So what I miss here, I already talked about Azure Storage. Oh, if by some reason you want to use Azure Storage as a file share, if you consider using SMB protocol start on 3.0, you will be encrypted in transit with your file share. And you can use a file share on Azure for an on-premise environment or for the Azure itself. So depends on, again, the model of we have in your solution. What else? We have a service called Keyvault. I don't know if every one of you have heard, but when you want to keep and store and manage keys and secrets, I mean passwords, on a safe repository, there are standards for that called FIPs 142 level 2 that just guarantee for you that you are good, that you are safe to keep those secrets and keys on an appliance. Azure has those services. It is called Keyvault. It is based on a HSM hardware that is provided by a vendor called Thales. So you can rely on this service if you want to keep secrets and keys safely on Azure. A good real example, it is, let's say you work with a developer team, an external developer team, and you don't want to provide secrets and keys for the application to access your database. When you use a service like that, you can provide just a URI, and then this URI is going to point out for the key that you are gonna keep on the key vault. So that's a very good example, but you can keep any type of secret and keys. For example, the keys for the encryption of your VM disks can be here as well. So maybe it's not directly concerned with security, but let's say you have a very secure, a very safe environment, but the entire region of Azure just go down, and then you lose all your services on Azure. So that's not secure. So you can use a service called Site Recovery that you can provide our replication for another region. That's a best practice about business continuity, but in my opinion, it's very tightly integrated with security. So just to mention, you can use an Azure service to replicate all your environment for another region, for a second region. And something very interesting here, it is that you can pay only for the storage part, and all your VMs can be there, but turn it off and you are not gonna pay for it. In the case of a failover, you can have automation written on Terraform, right? That's going to get your environment up and running again. So, of course, this type of scenario is going to depend of your RTO and RPO, and this is going to say to you how you should work. By replicating only data on storage, or by having some VMs already turned it on all the time. So we can have everything safe on Azure, but you have to monitor that in somehow. So on Azure, for everything, for every resource, you are gonna generate logs. And what do you do with those logs? You can use solutions on Azure, everything on the portal, everything in a unique interface. And you can see those logs on Azure. With those logs, you can create alerts. A good example, let's say you want to know if a bunch of servers on Azure is gonna run over 90% of CPU usage. You can be warned if that happens through text messages, or through email, or through phone call. But okay, and then you say, okay, I know I have something bad on my environment, and then what I do, you can get those alerts and transform on actions by using automation on Azure. So I didn't get your presentation since the beginning, but there are a lot of types of automation in Azure. Of course, Terraform is one of them that you can use, especially for infrastructure as a code. But you can simply get a bunch of action and use automation on Azure to trigger those actions in a specific order or not, or a simple, I don't know, or to run a simple code for you. So let's say, again, if a server or a bunch of server reach more than 90% of CPU usage, add a new node for me by using Terraform or not. But you can tell that to Azure. So you can see all of those automations and warnings on Azure portal in anywhere. You just need a browser. You don't need anything else. So just to finish here, we talk a lot about infrastructure environment that basically maybe represent 80% of customers. I don't know. But if you want to have a platform as a service scenario securely, you can also have a good example, like in the diagram, we have a storage account here. We have something that we call an Azure Application Service Plan that can run the hardware, the operating system, the framework according to the language you're using, and what you just need to do is deploy your code. Basically, that is this type of service. And here we have a SQL database as a platform as a service. I mean, you don't have to configure disks, servers, anything. You just need to tell to Azure, I need a database with such a size, with such a performance.
SQL as a service, does that integrate with Encrypt?
Good point. You have two ways of having SQL Server on Azure. One, it is the platform as a service that I'm talking right now. And you can also get a VM, of course, and install a SQL Server. For the VM running a SQL Server, you can rely on an Active Directory domain service because it talks Kerberos for authentication and LDAP as protocol. But if you're gonna use Azure SQL Database as a service, you have to rely on SAML and OAuth. That's what happened. And of course, if you synchronize your Active Directory with Azure Active Directory, you have both words. So what I'd like to finish telling you about platforms as a service with those three greatest example of service, because it's very, very well used for most of customers. It is that you can get all those services that originally is exposed to the internet. All of those services, it is exposed to the internet. But a couple of months ago, maybe more than 1 year, Azure now allows that you put all those services inside a VNet. That's so cool because all the protection that you create for your VNet is considered for those platforms as services. So that's one great point of security that I would like to mention. And of course, I just mentioned 3 platforms as a service, but we have much more. You can have Redis cache as a service. You can have CDN as we are talking. You can have Azure Search as a platform as a service to run for you. You can have services that make a row of a queue. So what I usually says for most customers, it is try not to be concerned about what Azure can offer to you. When you're going to do and design a solution for your environment, think about security in the highest level you can, and then bring it for someone that know about Azure and refine together. And then you can match what Azure can offer with what you need. And then you're gonna take a decision if that's enough or not for you. So there is no secret. There's no secret. You have a requirement and Azure offer you a bunch of services. You have to match those. And of course, the third and maybe the most important, it is your budget need to fit on that. So that's it, guys. I hope you have enjoyed. Again, you can send me whatever question you want. You can request any information. I'll be very glad to talk to you. Okay?
Thank you.
Thanks so much. Thank you so much. Oh, if any one of you want this presentation, I don't know if T is gonna provide you. Should I send to you, or I don't know? How do you do?
Presentation?
Yeah.
Upload it wherever you like, and you can either send it to me or just put the link right as a comment.
Cool. And then you, I believe that you can find it. Okay.
You'll see it in the comments on tonight's meeting. So you
Me?
Everybody, you'll see the what he's gonna put out. Will be a link will be in the comments of tonight's meeting.
Oh,
And
got
you
it.
can either post it yourself or you can send it to me and I'll post it.
Cool. Deal.
We'll just email you directly. We have your email.
Yeah.
Do that.
Yeah.
Perfect. And thank you, team, for inviting me.
Coming.
I be here all week. I work here on this office. So
Sounds good.
free coffee all day.
Free coffee is the most dangerous type of coffee.